Hi, this is Algebra 2, Lesson 90. We're going to talk about systems of three equations, and we're starting on page 374. The solution to a system of two equations and two unknowns is the ordered pairs where the graphs of their lines meet. So if we have 3x plus 2y equals negative 4 and 2x minus 3y equals negative 8, if we graphed both these lines, and here they are, we see the lines cross right here at negative 2 and 1. We can check the solution by putting these values of x and y into both equations. So we would have 3 times negative 2 plus 2 times 1 equals negative 4. And we would have 2 times negative 2 minus 4 times 1 equals negative 8. I'm going to run out of space. Alright, so we have negative 6 plus 2 equals negative 4. And negative 4 equals negative 4. So that's true. Or we have negative 4 minus 4 equals negative 8, and negative 8 equals negative 8. So that's true. So this would be the correct point for both of these equations, where the equations meet. If we have a system of three linear equations with three unknowns, the graphs of their points form a plane instead of lines in 3 dimensions. We can find the solutions by graphing and by finding the points that are shared by all 3 planes, but that's pretty complicated and you aren't quite ready for 3D graphing yet. It is coming, but not this year. So, we're going to solve systems of 3 equations with 3 unknowns with substitution and elimination. So, here we have x plus 2y plus z equals 4, 2x minus y minus z equals 0, and 2x minus 2y plus z equals 1. I'm going to label these A, B, and C just because it's easier to talk about them that way. And we're going to start by eliminating one of the variables. If we start by using B and C, we can eliminate the z. So let's start there. So we're going to take B, which is 2x minus y minus z equals 0. This is B. And we have 2x minus 2y plus z equals 1. So that's C. We're going to add them together. And we'll get 4x minus 3y. The z's cancel, equals 1. And we're going to call this equation D. Okay, so now we have one equation with 2 variables. We need another one so we can solve for one of these guys. So this time we're going to use A and one of these equations. So it would make sense to use A and B because once again we can add those together and eliminate the Z. So we're going to use x plus 2y plus z equals 4, which is A, and 2x minus y minus z equals 0, which is B, and add these together. So we'll have 3x plus y, the z's cancel, equals 4, and this one we're going to call E. Okay, so now we have 2 equations with just x and y. We're going to use these to eliminate either an x or a y. So if we multiply E times 3, then we'll have a negative 3y and a positive 3y, and we can use elimination. So we're going to multiply this guy times 3 on both sides. So that'll give us 9x plus 3y equals 12. And we can add that to D. So we'll have 4x minus 3y equals 1, which is D. And 9x plus 3y equals 12, which is e times 3. I'm going to add these together, and this is 13x equals 13. Divide both sides by 13, and x equals 1. Okay? Now we can plug this into D and E and solve for y. Okay? So we have, into D, we have 4 times 1 minus 3y equals 1. Into E, we have 3 times 1 plus y equals 4. Okay? So this is 4 minus 3y equals 1. We subtract both sides by 4. We get negative 3y equals negative 3. Divide both sides by negative 3, and y equals 1. Let's check that over here. So this is 3 plus y equals 4, minus 3, y equals 1. Okay, now we can solve. So we've got y equals 1, and we checked that. Okay, now we can substitute x equals 1 and y equals 1 into these guys to solve for x. And to check, we should do it to all three of them, if I have enough room here. So we have a, we've got 1 plus 2 times 1 plus z equals 4. For b, we have 2 times 1 minus 1 minus z equals 0. And for c, we have 2 times 1 minus 2 times 1 plus z equals 1. So this is 1 plus 2 plus z equals 4. So 3 plus z equals 4. So z equals 1. Let's check that over here. We have 2 minus 1 minus z equals 0. So 1 minus z equals 0. So z equals 1. And here we have 2 minus 2 plus z equals 1. Z equals 1, because that is 0. Alright, so our ordered triple, it's not an ordered pair anymore because we have 3 of them. So our ordered triple is going to be 1, 1, and 1. X, Y, and Z. And that will be your answer. Okay, let's try another one. These aren't really any harder than than with just 2 variables. There's just a few more steps, so it's a little more complicated, but you can do it. Okay, so we have 2x minus y plus 3z equals 9, x plus 2y plus z equals 8, and x minus 2y plus z equals 0. So if we use b and c, we can eliminate y. So here's b, x plus 2y plus z equals 8. It's b. And c is x minus 2y plus z equals 0. We add these together. We get 2x plus 2z equals 8. So that we're going to call D. Okay. Now we need to use a in one of the equations. So let's use a and b, and we're going to multiply a times 2 so that we can eliminate the y. So we'll have 4x minus 2y plus 6z equals 18, right? So that's a, all the terms multiplied times 2. And then b, this is a times 2. And then we have b, which is x plus 2y plus z equals 8. This is b. We're going to add these together, and we're going to get 5x, the y's are going to cancel, plus 7z equals 26. And we're going to call that E. Oop, that's a 7, not a 2. 7z. Okay, so now we're going to use D and E and eliminate either x or z. Those are not very pretty numbers. Looks like the common multiple of the x's is going to be 10, or the common multiple, or the common, multiple of the z's is going to be 14. I could divide this one by 2 all the way across and get x plus z equals 4. And that way I would only have to multiply it times 5. And I wouldn't have to multiply this one. So let's do that. If we divide all the terms in this one by 2, we'll have x plus z equals 4. Okay? You see what I did there? This is this divided by 2 on both sides. And now, because we have a 5x here, if we multiply all of this times negative 5, then we don't have to multiply anything times this one. Okay, so now we'll have negative 5x minus 5z equals negative 20. So this is D with some changes. And we're going to add that to E. So this is 5x plus 7, that's a 7z, equals 26. Add this mess together. The x's cancel. We have 2z equals 6. So z equals 3. Okay? We can put this into both of these and solve for x. So we have 2x plus 2 times 3 equals 8. So 2x plus 6 equals 8. Subtract 6 from both sides. 2x equals 2. So x equals 1. Let's check that by also substituting this into here. And we get 5x plus 7 times 3 equals 26. 5x plus 21 equals 26. Subtract 21. 5x equals 5. So x equals 1. Great. So now we have z and x, and we can substitute these into all three of these and solve for y. And yes, we could only do it to 1, but this is a good check. If it works in 1, it should work in all 3. So let's substitute it into A. So that's 2 times 1 minus y plus 3 times 3 equals 9. So 2 minus y plus 9 equals 9. Minus 9. Wow. That was a silly thing to do. Alright, we've got 9 plus 2. We've got 11 minus y equals 9. Minus 11 on both sides. And minus y equals negative 2. So y equals 2. Okay? Let's try it into B. X is 1. 1 plus 2y. But now we can put 2 into here. 2 plus 3 equals 8. So 1 plus 4 plus 3 equals 8. 8 equals 8, so that's true. Yay! Alright, let's substitute our x, y, and z into C. So we have 1 minus 2 times 2 is 4 plus 3 equals 0. 1 minus 4 is negative 3 plus 3 equals 0, which is true. Alright, so our ordered triple is 1, 2, and 3. Okay, let's try another one. we have x minus 2y plus 2z equals 2, x plus y minus z equals 3, 3 minus 2y minus 2z equals 2. So we're going to use elimination on A and C, and we're going to eliminate z. So A is x minus 2y plus 2z equals 2. And C is 3x minus 2y minus 2z equals 2. Okay, we add these together. And we get 4x minus 4y, z's cancel, equals 4. We can simplify this and by dividing all the terms by 4, and we get x minus y equals 1. So this is also D. This will be easier to use later probably. Alright, so now we need to do this again and substitute z with another 2 of these. So let's use A and B, and we're going to multiply B times 2 so that the z's cancel. Okay? So here's A, x minus 2y plus 2z equals 2. And now we're going to use B, and we're going to multiply both sides of B times 2 so that our z's cancel. So we'll have 2x plus 2y minus 2z equals 6. Don't forget to multiply the other side. Add these together and we get 3x. And as a nice bonus, the y's also cancel. So 3x equals 8. So x equals 8/3. This is actually E, for what it's worth. And it's also a substitution, a value for x. So now we can substitute this into D and solve for y. So if x equals 8/3, then 8/3 minus y equals 1. So y is going to have to equal 5/3, right? 8/3 minus 5/3 equals 3/3, which equals 1. So y equals 5/3. Okay, now we're going to substitute x and y into the other 3 and solve for z. So we have 8/3 minus 2 times 5/3 plus 2z equals 2. We also have 8/3 plus 5/3 minus z equals 3. And if I can fit it in here, we have 3 times 8/3 minus 2 times 5/3 minus 2z equals 2. Shouldn't have tried to fit it in there. Alright, we'll scooch everything to the left here. Oops, sorry, I shouldn't move my paper. Sorry. Alright. We have 8/3 minus 10/3 plus 6/3 times z equals 6/3, right? I'm just putting everything into thirds. So this is negative 2/3 plus 6/3 z equals 6/3. Let's add 2/3 to both sides. That cancels. We have 6/3 z equals 8/3. Alright, at this point we have thirds on both sides. We can get rid of these guys. We can just multiply both sides by 3, cancel the thirds on the bottom, and we have 6z equals 8. Divide by 6. And z equals 8/6, which is the same as 4/3. Okay? Let's try that over here. I'm going to squish everything to the left a little bit so there's room for this one. So this is going to be 13 thirds minus z equals, let's put this into thirds, so that'll be 9 thirds. And this is 3 thirds, because it's 1z, right? Alright, so we're going to multiply everything times 3 and get rid of the thirds on the bottom. So we have 13 minus 3z equals 9. We're going to end up with thirds again, but this is just a little easier to deal with. Subtract 13 from both sides. We have negative 3z equals minus 4. Divide both sides by negative 3, and z equals 4 thirds. Okay, let's try it over here. Sorry, this got a little squishy. Alright, so this is 24 thirds minus 10 thirds minus 2z equals 2. So this is 13 thirds minus 6 thirds. Z equals 6 thirds. Okay, once again we can multiply both sides times 3 and get rid of the thirds. So we have 13 minus 6z equals 6. Minus 13, minus 13, minus 6z equals 'Is this working? What did I do wrong? Oh, that's 14. Sorry, this is a 14. 14, 14, 14, and an 8. Sorry about that. Minus 6. Oop, not divided by. Minus 6. Oh, it is divided by. Now I'm brain dead. 7 equals negative 8 over negative 3, which is 4 thirds. Alright, I got a little confused on that one. This is why you check. And if I had done this one first, I would have ended up with the wrong answer. But because I did all 3 of them, I could see my pattern was breaking, so I could find my mistake. So take your time, check all 3. It turns out to be worth it in the end. Okay? That is it for this lesson. Try the practice problems. Let me know if you have any questions. And that's it.